For today's puzzle, we're going to go on a little journey back in time. Our journey takes us back to the Wild Wild West, Tombstone, Arizona in 1890. At large are two of the most wanted outlaws in the entire nation, notorious Ned Nelson and Carl the Killer Carlson. The town has all but given up on capturing these two, but then into town walks you, famous bounty hunter and puzzle-solving extraordinaire. So you walk over to the local saloon in those fancy little boots of yours, and barkeep tells you that there's a rich mathematician offering a reward for the capture of these two. After a shot of whiskey, he hands you this poster. You, being the experienced puzzle solver that you are, immediately recognize it as a cryptorhythm, a puzzle where each letter represents a unique digit and there are no leading zeros. You also notice some strange graffiti on the wanted poster and decide to trust it, that the letter N will represent the number 5 in this puzzle. So today's question is just, how much is the reward? In other words, solve this cryptorhythm. So can you do it? I bet you can. Sometimes in these videos, I give you a problem that isn't really realistic to solve without some hints. In this specific case though, I think you could at least get started. Maybe pause, see how far you can get, and then check back in if you need some help. If I were trying to solve this, what I'd probably do first is pick some corny Wild West background. Ooh, that's a little bit much. Yeah, that'll do. And then take advantage of the information that was given to me, that N is equal to 5. Since I know that each letter represents a unique digit, I can replace all my N's with 5s, and I can also eliminate 5 as a possibility for any of the other letters. And now in the ones column, since 5 plus 5 equals 10, and when we use our standard addition algorithm, we write the 0 in 10 and carry the 1, we can deduce that the D must be equal to 0. And it seems like a good idea to keep track of carried digits, so I'm going to go ahead and do that too. I think that's the end of the low-hanging fruit, so maybe it's a good time to use our hint for this video.
Next, determine A, then R, then C, then O.
Start with A? Okay, well, let's see. Oh, I get it, that's easy. E plus A equals E. A must be equal to 0, right? No, because we already decided that D was equal to 0. Well, that's weird. How can we add some number to E and get E as our answer if that number we're adding is not 0? The trick is we need to add 10. And you're like, wait, that doesn't make any sense. I thought these were each single-digit numbers. They are, but maybe we have a carry. In fact, we have to have a carry. And since the most you can carry from one column to the next is just 1, A must be equal to 9 so that we end up adding 10 to E to leave the E unchanged in this column. And note that not only did we need a 1 carried into that column to make that happen, but when we add 10 to E, whatever E ends up being, we'll end up carrying 1 into the next column. And then next, Hector suggested that we look into the R's. Well, there's 3 different R's, but this one on the far left gives us a fair amount of information. We don't know what C is equal to, but we're going to add 6 to whatever that ends up being, and that gives us a single-digit number because we're not carrying into the next column. So R must be pretty big. In fact, since we already used up our 0, C must be at least 1, and when we add 6 to a number that's at least 1, we get a number that's at least 7. Combine that with the fact that we've already used up our 9, and we can deduce just based on this R that R must be equal to either 7 or 8. Maybe we can use one of the other R's to figure out which one it is. This R doesn't tell us a whole lot, but this R does. Can you figure it out? Think about the parity of R. Parity is just a fancy math word for whether something's even or odd. We don't know whether O is even or odd, but regardless, when we add it to itself, we'll get an even number. Adding the 1 that we carried into this column makes the sum an odd number, so R must be an odd number. Therefore, it can't be 8 and must be 7. And once we know R, we get C pretty easily. We need 1 more than the 6 we already have in this column to get a sum of 7, therefore C must be equal to 1. Hector suggested that next we figure out what O is equal to. I'm not going to argue with them. So let's see, there's some number that when we double it and add 1 more, we get 7. And you're like, oh, it's 3. Well, it could be 3, but be careful. It could also be 8. 8 plus 8 would give us 16, and 1 more would give us 17, which again, remember, would cause us to write the 7 and carry the 1. So which is it, 3 or 8? Well, the big difference is if it's 3, we won't carry a number over to the next column. And if it's 8, we will carry a number over into the next column. So let's look at the next column. Can you make another parity argument? We don't know what S is equal to, but when we add it to itself, we get an even number. However, we can't end up with an even number because the sum in the hundreds column is a 9. In order to make that sum odd, we must have carried a number over into that column. So O plus 1 wasn't 7, but actually 17. So the O isn't a 3, but instead an 8. That gets us to the end of our hint from Hector, but I think we're good from here. Look at those S's. We need S to be a number so that when we add 2 of them together and then add 1 more, we get either 9 or 19. Well, let's see. To end up with 19, it would have to be 9 plus 9 plus 1, but we've already used the 9, so it must just sum to 9. 4 plus 4 plus 1 gets us there. Therefore, S must be equal to 4. And just so we don't get confused later, I'm going to make note of the fact that we're not carrying anything out of this column. With just 3 options left, we can probably process of elimination our way into the final answer. Let's see, if L were 2, W would be 2 plus 7, or 9, but 9's already taken. If L were a 3, 3 plus 7 equals 10, which ends in a 0, also already taken. So L must be equal to 6. 6 plus 7 is 13. That makes sense. W must be the 3 because I carried the 1 to the next column. That leaves only one letter, E, and one number, 2. So E must be equal to 2. If you're scared, you can check your work by making sure that the numbers sum to what they say they do. But I'm not. I'm confident that the bounty on the heads of our 2 outlaws is $723,970. Not bad. Because I'd like to leave you with challenge questions, let's take this absurd story one step further. Suppose you catch Notorious Ned and Carl the Killer, but decide the bounty wasn't quite enough. Rather than turn them in to the mathematician who offered the reward, you instead ask for more money. And how do you ask for more money? Well, with another cryptorhythm, of course. If you sent this cryptorhythm and the value of money was the additional funds you were asking for, then how much more were you asking for? Again, each letter stands for a unique digit, and we have no leading zeros. With those specifications, the solution should be unique. Feel free to discuss or ask questions or post solutions in the comments.